at the very moment, and I really extend my gratitude to you. And as you know that we have designed the webinar lecture series at different modes, and today's theme specifically is based on the shifting paradigm towards soils and land use management, issues related to land use, land cover, and whatever the aspects to be covered for the current scenario that is to be taken care of. And we are all very much eager to hear from you. As you know that there is gradual expansions of the cultivable lands, and there is actually affecting the forest ecosystem, and there is loss of the biodiversity per se. So in that section, what we want to find out that the environmental degradation and also the changing scenario of the climate, that is the talk of the issues, as a result of which we have chosen the topic shifting paradigms, because you know that there is a changing of the state lands management, which is very imperative for these seasons. And we are also concerned about the degraded land situation that is related to the development of the agroforestry, which can also enhance the sink potential of the carbon dioxide. So all these things will be covered gradually, and I think the students specifically will be very much helpful from the talk that will be delivered by the eminent speakers like you. So in short, I want to like to highlight your CV that I have received. Dr. Priyobrata Satra, Principal Scientist, Soil Physics, Soil and Water Conservation, has been working in Indian Council of Agriculture Research at Central Arid Zone Research Institute, Kazri, since 2003. He obtained his master's in agriculture physics from Indian Agriculture Research Institute, New Delhi in 2001, and PhD in soil physics, hydrology in 2009 from Indian Institute of Technology, Kharagpur. He visited International Center on Theoretical Physics, ICTP, Italy in 2010 to participate in college on soil physics for 12 days. He was awarded with Junior Associates in Soil Physics of ICTP for the period 2012 to 2017. He was awarded with Fast Track Research Grant for Young Scientist of rupees 25.5 lakh by Department of Science and Technology, Government of India during 2012 for developing dual purpose mechanical barrier to control wind erosion with simultaneous utilization of renewable energy. He was successfully completed NAIP sponsored advanced research training in geoinformatics at ISRIC World Soil Information, Netherlands for a period of 90 days during September to December 2013. He has been awarded with the ICAR Lal Bahadur Shastri Young Scientist Award in the year 2016 for his work on wind erosion and its control in Western Rajasthan. He visited University of Sydney, Australia for a joint training and workshop with the title Digital Agriculture for Food and Soil Security, training agricultural trade partners India during the period from November 4 to 19, 2016. He has successfully completed the project on solar farming, crop production, and electricity generation from a single land unit funded by ICAR under extramural grant of NRM division during the period from 2016 to 2017. Currently, he has been working on DST funded network project on revival of village ponds, ICAR funded project on modeling wind erosion processes, NABARD funded project on export-oriented program cultivation, and ICARDA funded project on improving water productivity in arid region. He participated in 21st World Congress on Soil Science held at Rio de Janeiro during the period from 12 to 17 August 2018. He published 60 research papers in reputed international national journals, 2 edited books, and 1 research bulletins at his disposals. So with this proviso, I don't want to take much time in between. So it is over to Dr. Priyobroto to continue his lecture. I wish you all the best. Thank you. Thank you.
Thank you, Dr. Dibyendu Mukhopadhyay. In fact, you were my senior when I joined BCKB during my BSc Agriculture Honors course. So from that time, I came to know about you with Dr. Saroj Sangha, and also my senior Dr. Abbas Sinha, who was my senior at BCKB. So I am actually feeling very good to actually, it is a homecoming to my own state and own colleagues and own universities, and it is feeling nostalgic for me that I am talking with people with whom we are connected for the last 20 years. A lot of my batchmates are there also who are working in UBKV. Just 1 minute, I am receiving a call. Sorry for disturbance. Actually, I received a call from my home. So it is actually a great feeling that I am talking with people from UBKB. My batchmate, Dr. Kaushik Pradhan, is there in Extension Division, and Biplab Mitra, he is also there, and my colleague, junior colleague Shovik Dev, with whom also I lot of discussion I used to do. So it is a great thing that UBKB has organized this. It is one type of interactive lecture series, I can say, and it is a very good initiative in my point of view, because actually it gives some overview of the current scenarios of soil science research going on in the country, which will be very helpful to students and the early young researcher, and not only the early young researcher, and all the people who are working in soil science specifically, because discussion should go on. Whatever I do and whatever you people do, it should be done together to achieve a better thing or better goal of soil science research in the country as a whole. So for that thing, I am very fascinated that UBKB has started this type of lecture series. And in this session, there is the main topic is shifting paradigm shift in soil science research and land use planning. And I will specifically talk on digital soil mapping, in which I am working for the last 7 or 8 years. Actually, I undergone a advanced research training on geoinformatics in the World Soil Information Center, Wageningen, Netherlands, for a period of 3 months. And from there on, actually, I learned different techniques on digital soil mapping, because that is the world center where all this digital soil mapping of the world is going on. So I worked with Professor Neil Badges, who is working as a global leader in digital soil mapping project, which is funded by FAO. And from there on, I found that this work should start in India. So with collaboration of IIT Kharagpur, my supervisor, Professor B.S. Das, we are working at different collaborative levels, and we are in the process to apply this technology in the current scenario as soon as possible. So we are targeting to develop networks on digital soil mapping project, and not only the digital soil mapping, what are the other interdisciplinary approaches required to do soil science research. That thing also is very essential. For example, how the hyperspectral soil signatures can be used for digital soil mapping, because conventional this what you can say, this weight chemistry method for soil property estimation, as you know all, that it is very time consuming and sometimes tedious and also costly, because all these chemicals are required to do the analysis. And our country is undergoing under soil health card mission also, with a big target of soil testing or soil health cards, preparation of soil health cards. So under this situation, the hyperspectral based scanning of soil samples and estimating soil properties with a reasonable accuracy might be quite useful. And that signatures can also be used in digital soil mapping program. So all these things, whatever we have started in collaboration with people from different parts of the country, for example, IIT Kharagpur, then IIT New Delhi, then from PRSC, Punjab, then from Goa, and also the NBSSLUP people. So we are forming a network to initiate this work as soon as possible, and we will be very much happy if we get some support from your university also in that program. So before starting my presentation, I am sharing this slide which I want to show during this presentation. I can tell you it is not a one type of one-way presentation. Always I want to interact with the students and faculties from the university, so that I can also learn something and what can be updated in the digital soil mapping program of the country. I hope the slide is visible to everybody. Okay, so
yes, it is visible.
Okay.
Yes,
okay.
yes, it's visible.
Okay, thank you. So under this major theme, this paradigm shift, whatever Dr. Dibyendu sir was talking about and Dr. Abbas also told, under this theme, I will talk on digital soil mapping and soil information systems, the modern approach of sustainable soil management. I think it will be okay for us also. So with this topic, before going to the presentation in detail, I can give 3 references of my publications, and from these 3 publications, actually, I did my prepared my presentation. The left one, the first one, is the digital soil mapping, the future need of sustainable soil management. It is a review published in the Springer book in 2020, just 2 months back. So in this book chapter, it is a 39-page book chapter. So in this book chapter, it is already mentioned the different aspects of digital soil mapping and how we can progress with this work in India. All these analyses have been given. Before this, I also published or compiled a book on soil resource and its mapping through geostatistics using R and QGIS. Here, all the example codes of R. I do not know how much you are acquainted with the R programming environment, but this is a most advanced programming language used in soil science research now. And both R and QGIS are open source software, so anybody can use it. And if you can form a group on this R in programming environment, then we can always share the codes written. For example, how to convert the Munchen color chart to other soil properties, how to convert this qualitative soil color value to the quantitative soil color value. Different packages are available, so I can use that R package or R programming environment to do the soil science analysis, and which is a very new thing. And I hope the students should use this facility or use this opportunity in their soil science research also. There are so many things available. I can tell you for one example, if you want to plot the soil textural triangle, we are in very difficult position to plot 50 soil samples in a soil textural triangle. Either I have to do it manually, or sometimes some Excel sheet based softwares are available. But in this programming language R, there is a specific package soil textural triangle. And if you put the just sand, silt and clay, it will automatically give you the soil textural classes. It will give a map where this soil textural triangle, where the samples are located. So it is very easy now. And in this book, all these R example codes are given, and how the digital soil mapping can be done, it is also given. And before this, in 2016, also I also published another review paper on digital soil mapping and waste management of soil resources, a brief discussion with few case studies. Here, all the case studies I have presented, where digital soil mapping throughout the India at different locations, how it is possible for sustainable soil management. So all these 3 references actually I compiled in my presentation to give a brief account of the digital soil mapping. Before going to this digital soil mapping details, I will just clarify 1 or 2 slides on the scale issues. Scale, how do we understand the spacing, extent, and support. These are the three scale triplets we can call, and how we can define in the field. Whenever we took sample from the field, we should be aware of these three scale triplets. Means, for example, spacing between two sampling points. Here in this left side, you can see three figures. One is spacing, one is extent, one is support. How it can be defined? Spacing defined means what is the distance between two sampling points. It is called spacing. Extent means what is the maximum distance between the farthest and nearest sampling point. For example, in a rectangular sampling area, the diagonal of the rectangle will be the extent. For example, in case of square, it may be the diagonal of the square plot will be the extent. So that is the maximum distance between the sampling points, two sampling points, nearest one and the farthest one. So this is called the extent. And support. Support is very, very important. For example, I can take soil samples from a small area. For example, 1 centimeter diameter. Using a spoon, I took some soil samples. And one person went to the field, and with the use of 30 centimeter auger, he took some huge soil sample. So that 30 centimeter circle area is called the support. If I collect soil sample using a spoon, it may be the support of 2 centimeter only. But in case of 30 centimeter soil auger, big auger, it will be the 30 centimeter support. So how much support area is required for actual assessment of soil properties? And lot of research in 1960s and 70s has been undergone on this support aspect. Everybody knows that for estimation of bulk density, we took soil samples using a core, and that core diameter is around 4.5 centimeter to 5 centimeter. Can you ask a question why this core size is 5 centimeter? Why not it is 10 centimeter? And why not it is 2 centimeter? And why not it is 1 meter? I can take soil samples with a big manual hydraulic auger, and using a core samples of around 40 centimeter, 50 centimeter dia. Then I carry it to the laboratory using a truck, and we can measure the density. And similarly, using a small 1 centimeter just a tube, I can take some soil samples from the field, and I can also measure the bulk density, because it is the weight by volume. Which one is correct? Because if we reduce the support area, the uncertainty of my measurements will be high. And if we go or increase the support area, the uncertainty of measurements will be lowered down. But the cost, the time requirement, the tedious measurement approach to take a sample of big support area is always not feasible. So there should be some compromise between the support and the uncertainty of the measurements. So for that thing, if we search in the literature, you can find for every soil sample research or soil sample analysis, this analysis and this research was carried out in 1960s, 70s, and it has been told that if you increase the support area, obviously the uncertainty will reduce, but we have to compromise. And for a bulk density, it has been found that 5 centimeter, 4 to 5 centimeter is the optimum one. Okay, if we increase further support area, you can get more accurate soil bulk density, but sometimes it is not required considering the cost of soil sampling approach. Similarly, for organic carbon analysis in laboratory, why it is only 0.5 gram soil samples should be taken for Wagley-Black method analysis? If I increase the support of that measurement, the chemical requirement will be bigger, and if we smaller down the support or the amount of soil sample, it is 0.1 gram, then my uncertainty will be high, because in the 0.1 gram soil sample, existence of different types of roots, sometimes clods, sometimes some pebbles, small sand particle may be there, and this will lead to a lot of uncertainty. So that's why it is 0.5 gram. Similarly, with this concept, for every soil property measurement, there is a particular support we have identified till now. And with that support, we have to work. And these three things is so important in the soil sampling scheme that we cannot neglect one and another. If I take some sample and if I tell I have taken sample at 1 kilometer distance, that is not sufficient to tell another person my sampling strategy. You have to tell three things. What is the spacing, what is the extent, and what is the support. Okay? And this support for normal soil testing facility, whatever we suggest, that in 1 biga field, you took 4 or 5 points, then you make a composite sample, and then that sample you bring to the laboratory for soil testing analysis. So in that case, my support has been increased from point to a 1 biga plot. So my support is 1 biga plot because I have collected 4 samples from 1 biga plot and then I mixed it to make a composite samples. That means my support of measurement is now 1 biga plot, not a sampling points basis. So whenever we took samples, instead of telling the spacing, you have to also tell what is the extent of your 50 samples. Sometimes it may also be feasible that I have taken samples, 50 samples, but within 1 kilometer area of a watershed area. And another people have collected 50 samples with a spacing of suppose 50 meter, but with the extent of 20 kilometer. So in that case, his extent is quite high, and the support also, as I told repeatedly, this will also be changed. So in combination, these three things is very much important. In the right side, you can see what is their implications on the soil property estimation. For example, you have taken sample where spacing is too large. Okay. So suppose, for example, this sine wave curve is the natural variation present in the soil for that soil property, and we take samples on this black dot or black circles. Okay. So we have taken sample in very large spacing, and so in that case I avoided this peak we avoided, actually not we avoided, but due to the large spacing, it was not captured in the soil sampling approach. So it will give a noise. It will not give the true picture of the soil properties which is inherent in the soil or inherent in the field. Okay. Sometimes if extent is too small, okay, suppose this is a trend of soil property in the field and I have taken sample only from this portion to this portion. So I have took samples only from one part of the total extent of the soil property variation, and I have taken samples from only this portion. So in this case, I will produce a trend only, means it will give a either decreasing trend or increasing trend. I will not able to capture the total variation of that property. And here, interestingly, the support. Okay, suppose if I took samples on this point and my support I have increased to this much, okay, so my support area is actually overlapping with each other. So in that case, the smoothing out will be happening. So it will be averaged one. So we cannot get this zigzag trend. Otherwise, you can take a mean type of curve of a soil property. Everywhere you can get the bulk density of 1.5 if you increase the support area. Or the sand content, you can get a constant value, obviously, if you increase the support area. So actually, you cannot capture the minute details of the soil property. So these three things are very important, and we soil scientists most of the time actually ignore this thing, and that's why I am keeping much more time in my presentation on these three aspects. And I came to know about this thing from the paper of one great soil hydrologist, Bloschall. He published a specific chapter on this scale issues in soil science research. You can obviously search on these issues, how the scale actually affect the soil property. Then I will give a big fundamentals of the soil map. and we can always correlate with this thing with the normal photography available in our mobile phone now. Okay, we always ask what is the resolution of your smartphone camera. Sometimes it is called the 10 megapixel, 20 megapixel, 30 megapixel. Sometimes gigapixel camera is also available. So that is called the resolution. And in soil map or digital soil map, this resolution and support are very, very important. Okay. For example, here I am showing that this is a field. I have taken 6 samples from this field with support is point, means my support of measurement is the point measurement, because it is a small sample taken from a small field or small area. And based on this 6 measurement, I did ordinary point taking to estimate that every grid, what is the estimate. So these dots are actually the estimates of soil property based on this 6 measured soil location. Okay, using ordinary point taking. And in this case, support is point and resolution is 1 kilometer. So this is actually this grid. It is actually 1 kilometer by 1 kilometer grid. And for this grid, only one value is predicted, and that is actually the center of that grid. So, for example, if it is a sand content map, so in this point it is suppose giving 56%, it is 55%, here it is 54, 52, 53, like this thing. So for every grid there will be one value, and that grid size is 1 kilometer by 1 kilometer. So in that case, support is point and resolution is 1 kilometer. So this is actually raster map, then we prepare. Okay, again in the lower figures, I can see that 6 samples we have taken, support is point, but here the resolution is 2 kilometer. I have just doubled the resolution of the measure or the predicted map. So in that case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 estimates will be given for that field. Here actually it was 5 into 1, 2, 3, 4, 5, 6, 7. 35 estimates were there in this case, but when he reduced the resolution, it is only 12. So for this 12, it is now become coarser, not the finer one, because I am increasing the resolution of my digital soil map. So again, this is the final map. Now, if you use the GIS, you know that using this 1 kilometer resolution map, you can always prepare a 2 kilometer resolution map. Or you can always prepare from this map any type of higher resolution, a coarse resolution map. From a fine resolution map, you can always prepare a coarse resolution map just by resampling technique. For example, it is smoothing average technique. This average of these 4 grids will be stored in one grid. So this is the resampling technique. So I have also gathered this 2 kilometer map by this first approach, then resampling, and also by this point approach, then resolution by this means also. Whether this gridding prediction and kriging variance will remain similar for these two cases, which one we should follow? We should prepare in a fine resolution map, then you can do resampling, or simply we can prepare the digital soil map with 2 kilometer resolution. This thing we can check always in my digital soil mapping program. Now I came to the basics of the digital soil mapping, how it came into existence and what is the basic concept. Actually the basic concept came from the father of soil scientists, we can say Dokuchev, 1883, and followed by Jenny, 1941. Actually, they coined the state factor or the CLORPT approach, CLORPT. This approach actually they coined. Soil forming process is a factor of 5 factors. This is called climate, organism, relief, parent material, and time. So everywhere where soil forms, these factors are actually governed in together to form a soil. And later on, Professor McBradley from University of Sydney, Australia, proposed another term, the Scorpion factor. Scorpion is actually the concept of the Dokuchev and Jenny, and linking it with the other disciplines of other disciplines rather than other disciplines than soil science. For example, soil or other soil properties is a factor of soil itself. Soil or other soil properties means, suppose organic carbon affect bulk density. Okay, so if it, here if it is the bulk density, then it may be the organic carbon, or it may be the sand content or clay content. So soil itself actually affecting the other soil properties. Then this climate, organism, relief, parent material, and here last one is the spatial position. Spatial positions, the another term actually coined in this CLORP approach, which give the spatial domain of the soil forming processes. Means soil of a particular location, how it is affected by the soil which is occurring 1 kilometer or 2 kilometer away from this position. So that thing also actually linking together. So based on this Scorpion theory, all this modern digital soil mapping approach is based on, and we are always actually exploiting this concept to prepare any type of soil map. Okay, so if we can divide this digital soil mapping and modeling approach, we can broadly classify this thing into three major categories. One is the geostatistical approach, another is the state factor approach, and third one is the Pareto transfer function approach. In the geostatistical approach, mainly the spatial variation of a soil property of a particular location actually is calculated based on semivariogram, and based on the semivariogram parameter, then using the Kriging approach, we can give an unbiased estimate of soil property at any unsampled location within that field. For example, in a 1 hectare field, I have taken 100 samples, and using that 100 samples, I can give an estimate of soil properties of that 1 hectare field at 10 meter resolution. So every unsampled location, I can give an estimate of the soil property using this geostatistical approach. Okay, so this is only governed by the spatial variation parameter of that soil property. And again, the spatial variation parameter or the semivariogram structure of the soil property, it depends on the type of soil property. For example, pH, soil pH. Soil pH actually, the spatial variation parameter is quite smooth in nature. Means there is a high correlation of soil property or soil pH for a particular location with a location which is further away from that location. For example, 2 kilometers away, what will be the soil pH? I can give an estimate based on a value 2 kilometers apart from that property. But in case of soil organic carbon, whether it is possible that knowing a value of soil organic carbon for a particular location, I can give an estimate 2 kilometers away from that place. It is very difficult. But for sand content, for clay content, it is somewhat possible. For nitrogen content, in a plot scale, it is sometimes difficult because so much variation in nitrogen content in the field it is there. But in case of soil EC also governs on the management practices, how we can using the irrigation water, what is the pedogenic sources of the salt coming into the soil surface. So all these factors are coming together to give a spatial process of the soil property, and that thing we have to capture by a sampling approach. And if I can capture the spatial variation parameter of that soil property, then I can easily give an unbiased estimate of soil property at any unsampled location. So whenever we are giving an unbiased estimate of any unsampled location, any soil property, along with that prediction, we have also to keep in mind what is the uncertainty of that prediction. Means what is my authenticity, that I can tell you that the bulk density or the soil organic carbon content of this place will be 0.35% and with an uncertainty value of plus minus 0.1. Okay, so if I know the uncertainty of your prediction, then only I can use your map or use your value. Otherwise, nobody will use your digital soil map. Most of the time, we are only focusing and that what is the what is the digital soil map, or what is the estimate of soil property available on that location. And most of the time we are neglecting that what is the uncertainty level of that prediction. For example, in a 1 hectare field, you took 5 samples, and for 5 samples you analyzed in the lab, and you found that nitrogen content at 5 locations, it varies from 200 kilo per hectare to 250 kilo per hectare, and you did some arithmetic average, and you tell that the nitrogen content of that field was 225 kilo per hectare based on the 5 samples taken from different locations within that field. So in this case, actually we are doing the arithmetic averaging to give an unbiased estimate of soil nitrogen content of that 1 hectare field. But how much true it is, we do not know, because any unsampled location, it may not be 225 kilo per hectare. And in case of arithmetic averaging, you can not able to get an idea what is the uncertainty of my estimation. But in case of kriging approach, every location you will give a predicted value, and along with that predicted value, it will give an uncertainty of the predicted value. And if you do it on your own hand by doing some soil sampling, you can see that along the sampling points, the uncertainty is quite low. And if you go far away from the sampling points, the uncertainty will be large. So again, the uncertainty plotting, uncertainty mapping is also very important, because along with the predicted value, I can also know where my uncertainty is low. And on those locations only, we can rely on the estimate. Other locations, I should not rely. Either I have to increase the sampling number on those places where uncertainty is very high, and then I can reduce the uncertainty by doing some more soil sampling, or gathering other soil factors which are affected in the soil forming processes. Because it is not always feasible that you will take 1,000 samples from a field to give a very, very close estimate of the soil nitrogen content. It is very difficult because it will time consuming, and it is not budget friendly also. It will take so much cost for doing the soil sampling, then carrying it to laboratory and doing the analysis. So all these things actually depends on your client or your stakeholder to whom you want to give the digital soil map. For example, I am doing a mapping of the soil pollutants. How much soil pollutants are there in a source sinks area? For example, in a effluent based area, there are some releasing the water from the industries which are polluted water, and that is disposing into soil. I want to know that surrounding areas, how these pollutants are spreading away, and what is the threshold value, what is the toxicity value, and I want to do mapping. So in this case, the uncertainty should be very, very low, because your toxicity value of the heavy metal content is quite important to the normal society. Okay, but if I go to a farmer and I can tell him that this organic carbon, nitrogen content, phosphorus content, and your field capacity, permanent wilting point, sometimes so much high uncertainty or low uncertainty is not required at all level. So depending on the stakeholder requirement, you can do the soil sampling. Soil sampling actually depends on the output of the soil sampling or output of the digital soil map. Based on that thing, we can prior model that what should be my optimum soil sampling strategy. Based on that thing, we can do soil sample and we can give a output to stakeholders. So I generally do, if anybody wants to know a digital soil map of my district or my village or my big farm, I would tell that how much uncertainty level you estimate, you desire. How much uncertainty level? 95% confidence interval or 90% confidence interval or 80% confidence interval. Whatever you want, based on that thing, I will do a sketch out a sampling strategy and I will do soil sampling. For example, if you want a confidence interval of 99%, then I took more soil samples. Instead of 100, I will take 1,000 soil samples. And he has to put some fund on me for extra fund so that I can give an estimate of 99% confidence interval output to that stakeholder. So it is actually a bargaining type of thing, that how much you are expecting from us, from soil scientists, so that we can do much more accurate value. It is no problem, but I have to know your requirement also. So in that geostatistical approach, this semi-variable and kriging is the basic fundamental thing. Along with that thing, nowadays these informations are available in digital platform in different sources. And for example, these all soil farming factors, for example, climate related, there are so many variables are available at different locations. In a regional scale, I can talk about, not for a farmer's field, climate information is not available. But if I know the climate variability or climate parameters variability within West Bengal, it is available. That source is, I can share you that what is the mean precipitation value, what is the mean precipitation in the month of July, what is the mean precipitation in the month of August, and what is the mean annual temperature, what is the mean winter temperature. For the long time, these data are available. So whether these climates are actually affecting the soil, as we know by Jeni's theory and Dokuchev theory. So if I know the information on the climate, I can slightly predict the soil property. Not the 100% I can claim that based on the climate I can predict soil property that this soil will be like this. For example, in arid region, the aridity index, it is a very governing factor in weathering processes. All these thermal processes are occurring. So using that value, I can predict the sand content of arid zone. Okay. Similarly, for West Bengal situation, I can guess that the mean precipitation value. Okay, this may be an important parameter to govern the soil property, or the total annual rainfall in the month of July for the last 20 years. It may be an important property or important variable to predict soil property. Similarly, for relief means a digital elevation model. How much undulation is there in the topography? Okay, so this information is available in the form of digital elevation model. It is freely available. 90-meter dam is available in the different sources. SRTM dam is available. Aster dam is available. And from that dam, I can extract different terrain attributes. For example, I can quote one attribute which is the wetness index, or the slope concavity, or the convexivity. Likewise, lot of terrain attributes we can calculate from this digital elevation model. For example, if the depression area is there, I expect that in the depression area in a natural topography, the silt content and clay content will be high. Why? Because erosion process always will take place from a higher elevation area, and it will carry by the runoff water, and it will be accumulated in the depressed area. So in the depressed area, I can always expect a high silt or clay content, whereas in the high elevation area, I always expect a low value of silt and clay, rather high value of sand content. So all these things are related with the relief or the topography. So if I get a correlation of the terrain attributes with the soil property, then I can model that trend and I can give an idea of the estimated soil value. So these things are actually called the covariates. Means based on the geostatistical approach, this thing will support your prediction process to increase the accuracy. And these things are increasingly available at different web platforms. So using this concept, people are more working on the digital soil mapping rather than on the geostatistical approach. People in the year 2000 or 2005-10, people used to do digital soil mapping using this geostatistical approach only. But nowadays, most of the work throughout the world are carrying using the state factor or plot approach. And so many machine learning algorithms are available to handle this large amount of data. Okay, I will go later on some case studies with this approach. The third one is the Pareto transfer function approach. Pareto transfer function means how we can estimate the complex soil property from basic soil property. For example, based on my experience and based on my field experience, if I know the sand, silt and clay content of a soil, I can tell that the water retention at field capacity of the soil will be around 18%, or the permanent wilting point will be 5%. If I take a soil sample in my hand and if I found it is around sandy soil, I can tell him that the field capacity will be around 12% of the soil and the permanent wilting point will be 5% of the soil. So available water capacity of the soil will be around 7%. So accordingly, you can do the irrigation scheduling. Because this estimation of the soil water retention at field capacity and permanent wilting point, it needs some sophisticated instrument, which is called pressure plate apparatus or the PF apparatus, where the water retention at a particular pressure has to be measured in the laboratory condition. So this water retention property is called a complex soil property. And if I get an idea of this complex soil property just by knowing the basic soil property, it will be very much good. So this approach is called the Pareto transfer function approach. Why it is important? Because if I map or if I develop the map of digital soil map of basic soil property, using this Pareto transfer function, I can easily combine 2 or 3 basic soil property map to a complex soil property map. And I will give an example which I did in my master degree program. Okay, so these are the actually total heart of this digital soil mapping. In one slide, I can tell you, if we follow these 3 techniques, you can easily do digital soil mapping in anywhere in your study area. Now I will go to the first approach, which is called the geostatistical approach. And the heart of the geostatistical approach is to identify the semi-variegated parameter, how the soil property varies in space. For example, I have here shown the spatial variation parameter of organic carbon, soil organic carbon, and it was carried out in a farmer's field in Jaisalmer, where I worked for 8 years. So it was published in Current Science in 2012, and this spatial variation parameter of soil organic carbon shows 3 main parameters, which one is called nugget, another is called seal, and third one is called range. What is nugget? Nugget is the small variations present in the soil property for that particular soil sampling scheme. So here in this case, the nugget is around 0.75. So this much variation I could not capture. If I took soil sample with a more lesser spacing or in the microscale soil sampling, if I did, then I should have captured this microscale variation, which we could not capture using my sampling scheme, which was around 50 meter apart. In a field, 50 meter apart I took sampling. Okay. So this is called nugget. More is the nugget, greater is the randomness of the variation, and lesser is the nugget, more is the spatial pattern of the variation. For example, if this spatial variation starts from 0, that means there is no nugget component in that variation. So whatever variation we capture, that is totally the spatial variation. There is no nugget component in that variation. But to obtain a pure nugget model in the field, it is quite difficult. And this is called the seal. Seal means what is the maximum variation I obtain in the field, and beyond that, the variation will not increase along with the increase in the lag distance. For example, in this case, it is around 120 or 130 meter sampling apart. Beyond 130 meter sampling apart, the variation is not increasing. It is actually flattening. That means whatever variation, spatial variation is there, this is within a range of 130 meter. Beyond that, whatever variation is present, that is random variation. There is no spatial variation exists beyond 130 meter. So what it suggests? It suggests that if I stand in the field and if I know the value of soil organic carbon where I am standing in the field, I can give an estimate within 130 meter surrounding my place where I am standing. 130 meter eastern side, western side, southern side, northern side, everywhere I can give an estimate. This is the circular field. I can give an estimate based on the value where I am standing. But if it is more than 130 meter, I cannot give an estimate. I can give, but it is based on the arithmetic average of the random variation. So this is actually the typical 3 parameters we have to identify: what is nugget, what is seal, and what is range of soil property variation. And using these three, we can give a ordinary kriging estimate of any unsampled location using a kriging weight. Okay, so this x0 is the unsampled location and xi is the measured location. And how much measured location I should take within a neighborhood, and for every sampled location I can give a weight which is called the kriging weight. And kriging weight, actually, if you go in details of the ordinary kriging process, I would suggest that you can go through the details of this ordinary kriging. Even in my that review paper which I mentioned, there also I give a very elaborate discussion. What should be the kriging, what should be the weight, how much sampling points should be taken during the kriging process. So all these things are there. So for every unsampled location using ordinary kriging, this Z hat means estimate of Z I can obtain from kriging approach. So this is called the ordinary kriging. And nowadays there are different variants of krigings are available. For example, block kriging, regression kriging, universal kriging, probability kriging, indicator kriging, and obviously the random forest regression. And some more variants of kriging are available now. The support vector machine learning, so many algorithms are there. KNN algorithm there, ANN algorithm is also there. So a lot of machine learning algorithms are coming into picture in the soil science research to do the digital soil mapping. And people from other parts of the world, specifically European countries and the Australia and USA, they are increasingly using this technique to prepare a digital soil map of their own country or even in continental level. So here I am giving examples, whatever I was telling in my state factor approach, that different climate variables are available. And this is available in the website worldclimate.org. All these information are available. You can download and you can extract for your own area. And here it is terrain attributes I am talking about. Sorry, it is not climate one. It is the terrain attribute which I generate from DEM. So this much properties I can generate, and then I can analyze the one-to-one correlation with every soil property. For example, elevation, slope, altitude above channel, hillside, profile curvature, plant curvature, terrain ruggedness index, terrain wetness index. For example, here 8 terrain attributes I have calculated from single digital elevation model. Then using these 8 terrain attributes, I can always get a correlation matrix with soil property, whether sand content is related with terrain wetness index or not, sand content is related to profile curvature or not. So this type of multiple linear regression analysis we can do first to identify which property is best related with the terrain attributes. If there is no relation, we can forget it about. We can try another covariate, but we have to search whether any relation is available with the terrain attributes or not. Similarly, the covariate maps of bioclimatic variables. For example, annual mean temperature, annual precipitation, temperature seasonality, precipitation seasonality, diurnal temperature range, annual temperature range, rainfall of wettest quarter. So all these things, there are 19 bioclimatic variables freely available in the website. So you can download in your own area. For example, once we have tried in West Bengal, for whole West Bengal, I have downloaded this world climate bioclimatic variable. Then I try to correlate with the soil property of that place. Okay, so that thing is also possible. Then in the third approach, the sparrow transfer function approach. For example, this is work done in IRI New Delhi. For example, the digital soil map of basic soil properties, bulk density, organic carbon, silt content, and clay content. This thing I know, and I want to know the digital soil map of fill capacity and digital soil map of permanent wilting point. And as you know, that fill capacity and permanent wilting point is a complex soil property, and it is affected by so many soil factors. So I have to, if I do the geostatistical modeling of the fill capacity and permanent wilting point, I should have taken much more number of soil samples in the field, because their variation is quite high in the field as compared to the basic soil property. Okay, so instead of taking soil samples from the field and analyzing the fill capacity and PWP for those soil samples and then do geostatistical modeling, I will not get a very good accurate map of FC and PWP. Rather, taking a fewer number of soil samples of basic soil property, because they have a good spatial trend, and if we generate this soil map, then using the Pareto transfer function, which is actually the function of organic carbon, silt, and clay, I can combine these 4 maps to a map of FC and PWP. And this is actually now increasingly used in different parts of the world. I have published this paper in Current Science in 2008. Now I see there are a lot of citations coming from different parts of the world on this paper for the last 2 or 3 years, and people are increasingly used. For example, in case of thermal soil thermal properties, suppose in case of thermal conductivity of soil water diffusivity, or the thermal diffusivity, then absorptivity, then our solute transport parameters, all these things can be easily predicted from the basic soil property. And every time you cannot create the digital soil map of absorptivity in your field, but using this approach you can easily create. So this is the new things people are now following, doing the complex soil property mapping. So now I am working on a project in Western India where this digital soil mapping work is carried out. So the approach should be like this framework. For example, what are the legacy soil data available for my target region? In case my target region is arid Western India. For example, in case yours, it is maybe the North Bengal. Okay, in the North Bengal area, first you have to search what is the legacy soil data available on those places. There are different publications on soil data available in the country, and the foremost one is the soil series level database published by the NSSLUP. They are the person who do soil survey and publish lot of soil series databases book. For example, in case of West Bengal, it is available with us also. The soil series data of West Bengal, along with the food sheet map, they are available. So from those places, I can collect the soil series data for my North Bengal area. Then some benchmark soil series database. Then again soil atlas prepared by state departments. Then local soil archives. For example, your university is working on those places, and maybe some other institutes are working on North Bengal area. So they collected some soil samples at different times during the last 20-30 years, and we can collect those archives in your study. And what are the published soil data? Different students are actually working at different places, and they always publish MSc thesis, PhD thesis, sometimes the journal paper, and I can collect for the last 20 years what are the soil science paper published in North Bengal area. I can search it in the Journal of Indian Society of Soil Science or in some agropetrology journal. So different journals available where we can search for published soil data available for your test region. So whenever we get all the soil data, we can do a special soil database of a region. And using this special soil database, you can check whether the sample size is sufficient or not to create a spatial variation. Suppose it is not sufficient, then you have to go for a probabilistic sampling design for gap filling. Means some more amount of data is required where there is some lacking points are there. There is a lot of gaps are there in the data in the spatial domain. So in those locations, again you have to go for soil survey, and you can fill those data by gap filling procedure. And if the sample size is sufficient, then you can go for final spatial soil database of that target region. Here in my case, it is arid Western India. Then we can go for digital soil mapping and validation. For example, ordinary kicking, regression kicking, random forest regression, then PTFH approach, all these things we can generate, and we can prepare maps of soil maps of target region. Then using the soil map, we can, what is the utility of the soil map? This soil map actually will be of great useful to a stakeholders if it is accessible to them. Suppose I collected soil samples from total West Bengal, 2000 soil samples I have taken, and I prepared a digital soil map, and it is available in my computer or in my department, but it is not accessible to everyone. So who will use it? And that is the questions we are facing from different time to time, that what is the utility of soil science research for a common man, common stakeholders, for a farmer. Whether every time I have to collect the soil sample from the farmer's field to give a recommendation to the farmer that, okay, your N content, P content and K content is this much, so you should apply this type of fertilizer. What will be about the soil water retention parameter values? What will be the other soil property value? What is the decision I should give to them? So for that thing, we have to prepare a soil information system. And this soil information system is the work of the computer science people. So I have to join hand with the people from the computer science department to create a soil information system. And these type of systems are available either in the smartphone, okay, or even in the web platform, or even sometimes in the hardware devices. I can prepare this soil information system so that farmers just click on the smartphone that this is my area, what is the sand content of my area, and you can give an estimate of the sand content of his area. Then if he knows the sand content, clay content and organic carbon content of the of his field, by using smartphone, if we can identify, then I can easily tell him what is the field capacity content of your area, what is the permanent building point. Then if he can calculate, then easily he can judge what is the irrigation scheduling pattern of his field. So this type of actually translating the soil science output to the common man is always required, in which we are lacking too much. And this is the requirement for the current time, that whatever soil science research we did throughout the country, and NBSS LOB actually did a wonderful job to do the soil survey work and publish different soil series database reports. Not only the NBSS LOB, different state universities have done lot of survey work in their respective areas and collected a huge samples of data, which is available in every soil science department of our country. You name UBKB, BCKB, PAU, even HISAR, everywhere, Pantnagar, everywhere it is available. If we connect with the people from different universities, I can collect around 7,000 to 8,000 soil data available in our country. For example, my dream is to create a soil database of the country with the network of soil scientist people. We are working in different state agriculture universities, ICR institutes. We can even parallelly match with the people from USA. They have developed a soil series database. If you can search in the Google, USA soil series database StatsGo, it is available for the last 10 years. Everybody can use that data. I can also use that data. I have used it. I have downloaded from their website, StatsGo, and I have did some analysis and modeling using the soil series database. So this type of accessing to the soil data by a stakeholder, it may be the researcher, it may be the farmers, or it may be industrialists, or any type of stakeholders. If they can access your data, then it will be very much useful. Otherwise, it is of no use. Whether I can create a very fine resolution digital soil map, it will be available in my department, in my computer, and in my institute, and which is going on currently. Because at my institute for the last 40 years, whatever soil archives are available, it is available in our institute. And people from QRT members, from RSC members, everybody asking now questions, what is the utility of 10,000 soil series data you have collected, but nowhere it is available to the public? And how a public institutes should survive on the soil science research, which is of no utility to the farmer? And that question will be faced by everybody now, because we have to give some tangible product as a soil scientist to the nation or to the stakeholders. Anyway, so this is the soil information system is required very urgently in our country, and we are lacking behind if we compare with the world. If we see in ISRIC website, if you can go that World Soil Information Center, there is a recently one soil information system launch, AFSIS, African Soil Information System. For every parts of Africa, the soil information system is available. You can search in your website also, and if you click on a portion in Africa, you can get a soil property at profile wise, and you can use it on your own purpose to take a decision. Similarly, soil information system for Latin America and Caribbean countries, SISLAC, it is also available in the website. It is freely available. Similarly, for Argentina, there is a CICINTA. There is a soil information system for this Argentina people. They are also available. In case of Australia, they have also created their own soil information system for their own country. For USA, it is obviously available. So for every parts of the world, soil information system is available, but it is not available till now in India. And NBCS will be actually taking a lead role to create a portal called Bhumi. If you visit the website of NBCS LUP and if you click on Bhumi, so there is a soil information system. Now they are creating based on the soil archives available in our country. So this is the actually requirement of the present time. I will not take much time. I have already taken 1 hour time. Rather, I will discuss few more things by interaction with them. I will go through in details what are the different soil properties we can do. This is actually specific soil water retention parameter, how we can characterize them and how we can prepare the soil property map in a digital format. I'm skipping this slide because I have already spent 1 hour time. This thing I want to mention, this proximal soil reflectance, how the hyperspectral signature can be used increasingly in the soil science research. Suppose this is a soil reflectance spectra, and you can see the variation of the reflectance spectra based on the soil property. From around 10% to 60% variation is there in the reflectance based on the soil property. For example, if there is more soil carbonate there will be a dark color, and this dark color actually reflectance will be very much less. So for these soil samples, I hope or I expect the organic carbon content of this soil will be less. Again, this absorption peak, if you can detail analysis of this absorption peak, the peak height, the peak soldier, and the depth of that peak, how much it is varying with the soil property. So in-depth analysis we can do. And for chemical constituents of the soil also, the spectra will be changing. So for hydroxyl group presentation in the soil, what will be spectral change? If the water content is increased, what is the spectra change? So every detailed analysis of the spectral data processing we can do, and we can develop an algorithm. And if this algorithm is developed in our country based on the soil spectra, using remote sensing satellite images, where lot of bandwidths are available nowadays. Forget about the LIS 3 camera and IRS, Indian Remote Sensing Satellite, LIS 1 camera, LIS 2 camera, LIS 3 camera. Now, very, very fine resolution cameras are available in the remote sensing platform with different bands, spectral bands. For example, if you search on Landsat, Sentinel, all these remote sensing platforms, data are freely available. If I can develop a very good algorithm based on the spectra, we can translate this spectra-based algorithm to the remote sensing platform for a quick assessment of the soil property during the summer period, when cloud cover will be less and soil will be more or less remain without any type of vegetation. So during those time, we can estimate the soil property in a quick time. So this is actually a sand content map prepared using the random forest regression approach, using all these bioclimatic variables I have shown earlier, and using all these terrain attributes. So around 30 inputs I have taken. A lot of soil properties, lot of bioclimatic variables, lot of terrain attributes. Then we did random forest regression modeling, and we got a very good accurate sand content map of arid western Rajasthan. For a large region, I have prepared this map. Similarly, I also worked with BCKB with the collaboration with our renowned teacher, Dr. Saroj Sandal sir, one of his PhD students. I did work on potassium dynamics in Goyaskur village. And I did publish this paper with one of the students, Saurabh Chatterjee, in 2015 in Environmental Monitoring and Assessment, where I did the special variation of N, P, K, and also the different versions of K. And interestingly, we found that under intensive cultivation, how the potassium dynamics is affecting in the Goyaspur village. Where banana cultivation is more, the exchangeable potassium percentage is lowering down. Where bananas cultivation is not there, their available potassium is quite high. So this type of trend we can found. The crop management practices, how it is affecting the soil property at a regional scale. For example, here I am showing the map of organic carbon, available nitrogen, available phosphorus, and available potassium. I am not showing the details of different fractions of potassium, which was more interesting part of that study. So just for example, I am showing you, you can go through the paper, which is freely available in the website. Then again, for a farmer's point of view, how we can manage the carbon content of his soil. So for that purpose, actually, in a single form, I prepared soil organic carbon map of different blocks. And here I can see the soil organic carbon, this white portion, it is 2 gram per kilo, means 0.2%. It is arid zone, obviously. So soil organic carbon content we cannot expect more than 0.1. And so in this field, we found there is a rangeland, grass cultivation is there. So grass cultivation is always beneficial for farmers, or the rangeland is always beneficial for farmers in terms of organic carbon content or organic carbon sequestration. Rather, this portion is intensively cultivated. Groundnut is being cultivated throughout the year. So here we are actually depleting the organic carbon. So this type of trend easily we can do using the digital soil mapping approach, and based on that thing, we can take a decision that how we can rotate this cropping pattern. For example, in this block, next year I should cultivate groundnut, and here I can grow for 4 or 5 years the rangeland or the grass component. Based on the livestock will survive. Similarly, the field capacity map and permanent wilting map. So this is the field capacity map and this is the permanent wilting map. So these two maps, if it is available to any type of policy makers, so they can easily judge which type of crops we should grow in this region. For example, I cannot suggest groundnut to be grown in a sandy soil where infiltration characteristics is very low and water retention is very poor. So on those regions, I can always suggest to do some cropping which is more preferable for a loose sandy soils, rather not recommending the crops which are high water requiring. So based on this digital soil map of water retention, I can take a decision or policy level decision on the land use planning. Okay, see, just this is an example. Lot of digital soil maps can be taken together, and if you do the fuzzy classification of this digital soil maps, you can get a decision that what should be the land use planning for those regions. For example, currently I am working for my institute's own field. This is the electrical conductivity, soil EC. Interestingly, I found that this is the red region because our institute is mainly mandated to do work in the rain-fed cultivation. No irrigation source was available earlier, but with the advancement of civilization, everybody is now trying to utilize the groundwater resources also. Although it is very scarce, but sometimes we are using where it is available. And using the groundwater resources for cultivation in arid region, everybody knows that it will create the secondary salinization. Means bringing out the water, and that poor quality water when applied in the field on the soil surface, slowly it will accumulate in the soil surface and it will build up the soil EC. And this trend is easily captured in my recent work in the soil EC mapping. So these blocks are now being heavily cultivated with irrigation water. And there is a sudden jump in the EC value from the normal, where these agroforestry plantations are there. Here it is almost green. There is no EC value of 108 to 140. But in this region, where irrigated agriculture are being practiced now for the last 2 or 3 years, we are getting an increasing trend of EC value. So if I know this type of trend in the digital soil mapping product, I can always take a decision. No, you should not do this thing. You always better shift this cropping pattern or do a change in the management practices in this field. I have talked about this spectral reflectance in the visible near infrared and short infrared, and I was talking about it, how we can check the correlation of soil properties with this soil spectral reflectance at different nanometer. For example, here we can see pH and EC. EC is negatively correlated. pH is negatively correlated with the soil spectral reflectance. So for every soil property, likewise, I can calculate. Then from this correlation plot, I can identify the peak. For example, it is sand content, and this is the peak. So here the value is around 0.4. Correlation coefficient is around 0.4 or 0.39. So what is the nanometer region? So this is the 1950 nanometer region. There is a high correlation obtained. So using that 1950 nanometer spectral band, I can always utilize further to identify that this band is very useful for predicting the sand content. Okay, so further analysis should be carried out on this aspect. And if you see that every soil property, this peak is observed is around 1950. So 1950 nanometer is a specific band region where if you do the detailed analysis, you can get a more detailed picture of soil property. So this type of actually pre-analysis we should do. Sir. 1000 sir. Sir. Okay. So this is actually done by the peak analysis we can do using the continuum removal factor. That this is the suppose peak, and what is the lambda minimum, lambda maximum, and 1930 is the peak region, and what is the depth of that peak from this soldier. Suppose this is the two soldier. If you can join this soldier, you can identify the depth. So depth also depends. So using that thing, you can calculate the continuum removal factor. Okay. So this factor, then you can correlate with the soil properties. Again, you can do the principal component analysis of the soil spectra, and using the major principal component, you can correlate with the soil properties. Likewise, we did a lot of spectrotransfer function. From spectral soil property or spectral signature, how we can estimate the soil properties. That thing we did carried out for different saturated hydrochloric conductivity and the water retention parameter of Van Gunningen model alpha and N. So these parameters now can be predicted using these spectral signatures. And that thing actually we published in Geoderma in 2009. And this term was coined for the first time, spectrotransfer function approach. Likewise, perotransfer function, using the soil property, we can predict the complex soil property. Here we have used the soil spectral signature to predict the complex soil property. So this spectrotransfer function is much more useful now to develop algorithm for different regions of the country. And using that concept, we prepared we took some soil spectral signature with collaboration of IIT Kharagpur, and we did survey in the desert area, and we prepared using a Landsat remote sensing platform. We translated that developed algorithm in the Landsat satellite, and we predicted the sand content map. So this is an example I have shown here, that how the hyperspectral signature can be useful in quick time mapping of soil properties. I am not going into this detail, but I can tell you the this fuzzy classification of soil properties. Fuzzy classification means we know the alpha, n, and ks, means we know the water retention parameter alpha and n of the Van Gunningen water retention model, and also the saturated hydrochloric conductivity. If we classify these three together, we can get a fuzzy classified map. And this is the N-basis LUP map available for the same watershed. Which one is more better? This map actually based on the survey, field survey, and this is actually done by mathematical calculation using the digital soil map. So it is more accurate in terms of soil hydrological aspect. So in case of soil hydrological modeling, we are always using a soil input or soil as a grid, as an input, to provide the basic soil parameters of that watershed area, so that runoff water using the Green-Amto model or the SCS curve number method, these two methods are used to create the runoff. Okay. These map actually based on only soil texture, and this is based on soil hydrological properties. So I expect a better modeling from this fuzzy-based classification of the hydrological soil property rather than the conventional soil texture-based classification. And I proved it that in a soil water modeling approach, this fuzzy classification work is much better. So this is the concept of the pedohydrology. How the pedology or soil science work can be combined with the hydrological work or hydrological modeling work. And this work is very, very important in our application now, that in NBS SLOP you are doing a lot of digital soil mapping. But in the hydrological study also, I can using this concept to create a hydrological similar zones in a watershed area or in a region or in a river basin, and then we can model the runoff and sediment load in this watershed. Again, the sampling extent and density, as we discussed earlier, how it is affecting the scales. Means, for example, it is map of Jaisalmer region. It is a single form. It is IRI form, much more higher scale. Then it is the Chilika Lake watershed. It is 42 kilometer square area. Then again it is total Rajasthan state, much more higher. Then it is agro-ecosystem scale, arid western India, and then it is total northwestern India. So at different scales, I have collected soil samples. Okay. For example, this area is 73 hectare. This is 278. This is 4200 hectare. So likewise, this area is increased. That means the extent of this sampling is increased. And if we see the sampling number, and if we calculate the sampling density is quite high here, but it is quite low here. Then I have prepared that how the sampling density actually affect the soil property estimation. Then again, if we increase the support area, then how we can increase the accuracy and how we can lose the uncertainty of my estimation. This thing also is possible. You can always try in your own area also. Then I will come to some application part. This is the soil information system we are now developing, and using so many computer science background, because it is developed in Python language, and we need to know Java language also, and obviously the PHP coding is required. So this is actually the concept is that it is a Google map. I have taken a key from the Google by requesting that I will use it for research purpose. Okay. Then they will give a key. By using that key, you can use the Google map. So in that Google map, if you put this balloon, if you can drag and move this balloon anywhere in this arid western area, it will give a ladder and long in these places. Okay. Otherwise, if the latitude and longitude is known to you, you can put an input here, latitude and longitude. Then you click on show point in map. So obviously this balloon will move. Then extract data from digital soil map. So for this location, then in the background there are 4 digital soil maps I have put it: sand map, silt map, clay map, organic carbon content map. So on that point, what will be the value of sand content, silt content, and clay content and organic carbon content? It will be fetched from the digital soil map to this web interface. So now you know this sand content, suppose it is 85, 8%, 7%, and 0.1%. So this value will be stored here. Now, using this pedotransfer function model, again, if we click, this value will be appearing again here. And using this input, I can calculate soil water retention parameter. C is water retention at FC, water retention at PWP, available water capacity, steady state infiltration rate, Van Genuchten parameter alpha, Van Genuchten parameter n. So all these soil property I can estimate for that location. So anywhere I can move this cursor and I can check this value. So this type of web-based soil information system we are generating for Edit Western India. Then another platform we are doing the Android app. Okay, suppose this is the app available in Ishdik, Soil Info. You can check it by downloading in your own mobile smartphone. Soil Info, it is a very good soil information system available. We are developing at Kajri Jodhpur digital agriculture. In the digital agriculture, I have actually developed up to this point that soil moisture content estimation, FCPWP, then instantaneous soil moisture using IoT devices, how we can get the soil moisture value to our mobile app. We have already done the 80% job of this case, that IoT sensor, how we can connect with the mobile app. Then I can do the irrigation scheduling. So these three things we have developed at different level. Still it is in the development stage, and soon we can develop or launch this app soon. And these are the different Android app or softwares available in ICR system. For example, it is the ZipCal developed by CSSRI Karnal. It is the fertilizer calculator app developed by ICR Research Complex Goa. And this is the petrotransfer function model based Kajri soil moisture calculator, which is available in our own institute. You can always download it and you can use it. That using the known sand, silt and clay content, you can give an estimate of field capacity, permanent dwelling point and available water capacity. So these are the different types of apps and softwares available now. Then in the next step, actually, we are targeting, this is the future. Everybody is talking about the IoT, then machine learning, then cobotics, robotics. Cobotics means co-robots. So here I am giving an example, and we are trying to do a work on the solar PV pump based irrigation, totally automated. Sitting at Jodhpur, I can even monitor the solar water pumping system at UVKB Kundibadi. I know the soil moisture content. I put a tensiometer there. I took the tensiometer value. Suppose if it is reaching 0.8 bar, then I can in the smartphone, by sitting itself here, I can start the pump and it will irrigate. Whenever it will reach to 100 millibar, I will stop the pump and the pump will be stopped. So this type of systems we are now developing at our Kajri. First, this should be developed this should be monitored anywhere in the world. By sitting at a very remote location, you can monitor your own field. What is the soil moisture level in your field, and accordingly you can do the irrigation scheduling. And in case of policy level planning, we are talking about the sustainable soil indicators. And one of the main criteria of any soil indicators is that it should be easily measurable and quantifiable. For example, organic carbon content or some erodible fraction factor in case of wind erosion. So that type of map we can generate, and we can take a policy level decision that how much changes are occurring under climate change or this thing. So these sustainable soil indicators can be easily calculated or computed using the digital soil map. Then again, another area of digital photography, and using digital photograph, how we can estimate the soil property. Just by taking a photograph using your smartphone in the field itself, can you estimate the soil moisture content? Can you estimate the nitrogen content? Or any type of machine learning or artificial intelligence algorithm can we apply on this digital soil maps? For example, here it is 100 soil samples taken from different parts of Western Rajasthan I have taken. Then I have prepared a digital soil library. Then using R code, I extracted all these R value, G value and B value of all this soil property. And based on this color, soil color, different indices we can calculate. Brightness index, saturation index, hue index, coloration index, redness index. Again, using this color value and color indices, we can develop an algorithm to specifically estimate any type of soil property. And we are working on it, whether the color of soil changes with applying soil moisture or applying irrigation water. And in arid soil, it is quite prominent. Whenever in a yellow colored soil, you apply irrigation water, suddenly color is changed. For example, here I have developed in laboratory now only. For example, it is a soil from Jaisalmer with a dryness of 0%. This is Chandan, this is Osia, and this is Jodhpur. And whenever we are increasing the moisture content, the color tone is changing. You can easily visualize this thing. And we quantified that change using this RGB model. And we can get a good trend using the soil moisture content and this RGB value. So using this information, we are now trying to apply this machine learning and artificial intelligence technique, how far best we can calculate the different soil properties. And from IIT Kharagpur lab, our junior colleague who worked in UVKB earlier also, Somsuppa Chakraborty, recently published 2-3 papers in Geoderma. Based on smartphone camera, he claimed that he can calculate the soil texture or the estimate the soil texture with around 90% accuracy. And even he has developed another acoustic small devices. Using the devices, by sound vibration, he can estimate the soil moisture content. So these are the 2 papers I found he has published from our BCKB junior colleague. He is doing wonderful work. So this type of work actually can be easily translated to the farmer's field, obviously with far more validation of that model. Validation means that different soils, how it is working, what is the feasibility of that machine, and how it can be done. All these things can be checked and it can be applied in the field itself. Again, apart from this web platform, we have also developed handy soil moisture calculator. This is a hardware devices, because we thought that in every farmer's field, smartphone may not be available. So actually, this is the live model I can show you. This is a small box. This is a prototype model. This digital soil moisture calculator. Actually, I want to make this calculator in the form of normal calculator, where we can calculate sand content, silt content, clay content. If I give input in the calculator tab, it will be field capacity, permanent wilting point, then available water capacity, then nitrogen, phosphorus, potassium. All these keys will be available here, and farmers can easily take a decision on their nutrient and water management decisions. So these are some upcoming things. I am not fully understood till now, but I am still learning, but it may be the feasible one. That's why I have shared it, and we are trying to get some opinion from your side also. And this is the latest work, how the legacy soil data, which is available in our country, can be used. And it is published in 2020 in Nature Scientific Reports with collaboration from IIT Kharagpur. And this is one of our junior PhD students from IIT Kharagpur, Poulomi Chakraborty, did this work with collaboration of Kajri Jodhpur, myself also a co-author of this paper. And in this paper, we clearly showed that whatever digital legacy soil data is available, it can be utilized in a best way to prepare different types of digital soil products or petrotransfer function approach. So this is the scheme we propose. So this legacy soil data, then ranges of response and predictor soil properties you have to check. Then geostatistical analysis we have to do. Then some modeling, nonlinear relationship between predictor and response soil properties. Then we have to identify a training data set having a locational similarity, means with the test data set, then spatial correlation response, then maximum correlation. Then using all these techniques, if we apply, then you can develop a robust petrotransfer function for predicting simple soil properties, complex soil properties. For example, CEC in this paper we mentioned using the soil property of clay, pH, and SOC. So with this thing, I will end my presentation. It took around 1 hour and 30 minutes. It is a quite long time I talked about. And this is actually work rather than soil science I did in Kajri Jodhpur, the agrivoltaic system. In the thank you slide, I intentionally put this thing because last 8 years I worked in energy science rather than doing soil science. I was doing the soil PV applications in agriculture, and this is a 1 crore project I completed recently in 2018. And this is the actually future requirement of our country also. How the solar PV system can be utilized in a better way, and we are running a national solar mission. So that's why if anybody in your department wants to work on the renewable energy applications in agriculture, in solar PV pumping system or in the agrivoltaic system, you are always welcome to connect to Kajri people. So thank you very much. Thank you.
Thank you very much, Dr. Chhatra. It was a very nice presentation, and it has given some ideas about the how you are working in arid region. Although we are staying in an area where we have 3000 millimeter rainfall yearly, but still what we are seeing that what you have shown us in the last slide, that solar pumping, it is being promoted here in our area also. And some of the farmers field now, Government of India is through Government of West Bengal, they are giving some this drip irrigation, and these types of irrigation facilities are being provided in order to save the groundwater. So thank you very much. Now I will ask the students to ask question, because I think he's a man of soil physics, and he's working a lot on water, and you have seen how different softwares they are trying to develop. And I am very thankful to you, Dr. Chhatra. You gave us some idea that measuring moisture is very important, right?
Yes,
so if although we have 3000 millimeter, but there are periods when there is a what I will say, deficit of water in the farmers field, and they are not very, they give water in just any way, they just pump out and they give it on the field, so it's wasting the water. So future we'll have to think of it. So students, please ask, feel free to ask him. Don't lose this opportunity.
I just want to say the two students that you can treat me as a senior from your university, because I did my all the things from my university in BCKB, which was another campus at that time in 94 to 99, this Pundivadi campus. Now it is a university. So you can always treat me as a senior of yours, not as a faculty.
So I see that one of the students have put up lot of question in chat box. So I will request him to ask directly. Subhadeep, you can ask him one by one.
Thank you, sir. Myself, Subhadeep Mondal. I am doing my PhD in soil science and agricultural chemistry from UVKB. Sir, I have some questions that can spectral smoothing be applied for every data set, or there are some of the limitations to do so?
Yes, spectral smoothing is need to be applied on every data set. Otherwise, you have to first identify the noise in the data. If there is any noise is there, then you have to smooth out that noise. And I hope it should be applied on every data set first to develop a spectral model or a spectral algorithm.
Okay, sir. Sir, in many of the publications, they have shown that they have used the Savitri-Golay smoothing. So, is it always a better approach, or we can also use that average method, moving average method for smoothing?
Regarding this question, I cannot give you a so specific answer of this model, because I have not recently working on the spectral model aspect, spectral modeling or data pre-processing. I can suggest you in my collaborator who is from Kerala, Mr. Saurabjit. He published a paper in Geoderma, spectral data pre-processing. There he has discussed all these issues. And if you want, I can connect you with Dr. Saurabjit to get a better answer on this aspect.
Okay, sir. Is there, sir, any method for assessing accuracy of IDW interpolated map, or simply kriging is a better approach? So means we can do
this is a question of very important nature. IDW actually inverse distance weighting. It is a classical interpolation. Classical interpolation, you know that in a sampling field with a change in space, how much property is changed, that classically we can calculate. So in soil property, it is not applicable too much, and IDW is not preferred over the Kriging approach in any way. Okay, so is there any plugin in QGIS for Kriging? Yes, lot of plugins are available for Kriging, and I would rather suggest you, because since you are working for PhD, I hope.
Yes, sir. Yes, sir.
So you first use the R. In R, there is a package called GSTAT, and using that GSTAT package, you do all this analysis. And since you are using QGIS, it will be of great help to you using the GSTAT package of R.
Okay, sir. And sir, in a semi-variogram model, that if we get a nugget by seal ratio of less than or equal to 0.25, so we generally consider it as it has a strong spatial dependency and it is a good model. But if we get a ratio of greater than 0.75, so it is a poor model. So is it because that the spatial distribution of the points and we can change it in the course of study in the later steps, or simply it is the error of sampling, like not a good spatial dependency or spatial distribution of the sampling points?
This is also a very good question. And where from you get this 0.75 value? This is the anybody has written this, that if it is more than 0.75 it will be good, and if it is more less than 0.75 it will be good. Actually, no spatial statistics people cannot write a single threshold value that if it is nugget to seal ratio is more than 75, it is of weak spatial dependency. If we read the paper from Webster, Oliver, then Gerard Hewlink, they are the leader of spatial statistics, and I put questions to them also, because I worked with Gerard Hewlink, and I put the same question to him also, that whether I would go for Kriging if my nugget to seal ratio is more high, even more than 0.8. He suggested me that you can go for Kriging even if your nugget to seal ratio is 1. Means if it is a pure nugget model, you can also go for Kriging, because advantage of the Kriging is that every unsampled location you can get an estimate, and you can always get an estimate of the uncertainty, where in normal case you cannot get. So any type of random variation also using the sequential Gaussian simulation, this is called SGS. In those cases, you have to apply for those approaches, not the ordinary Kriging approach. And second approach may be this spatial weakness may be due to the presence of trend in your data, and this trend may be due to the directional trend, maybe due to the northern and southern trend, and that directional trend should be removed first using the regression Kriging approach, or the trend due to other covariates. So this trend you have to identify in the data, and if you detain the data, you can get a better noise to seal ratio. So these are the actually some advanced analysis you have to do in the spatial analysis.
Okay, sir. And sir, what are the semi-variogram models? Like most of the models I have seen that they have using circular model or spherical model and Gaussian model or K-Bessel model or J-Bessel model, like that. So so how we can choose this? It is based on the RMSE value or nugget by seal ratio, or we have to consider all the things that
you have to check it by using the RMSE value only, or the SSR, sum square of residual, or the root mean square error. These are the two criteria for a single experimental variogram. For different theoretical semi-variogram models, we can calculate the RMSE, and the model with the lowest RMSE value will be taken as a best fit model. But for my experience, I can say that I am always using the 4 basic model: linear, Gaussian, spherical, and exponential. I am not going to Hall effect model or the circular model or the K-Bessel model or the Maton model, whatever you are talking about, because it is somewhat complicated in nature. But I have also used REML EPLAP approach, residual maximum likelihood approach. It is also another approach. It is also available in environmental art science. I published in 2012. So that is another approach you can also apply. But these interpolation approaches are quite complex in nature. That's why people always avoid it. Sometimes avoid it. So I would prefer to use only these 4 standard theoretical model first. If it is not fitting at well, then you can go for this complex Bessel model or this Matter model or the whole effect model.
Yes, sir. Sir, there is a study. I have performed this study in kernel. So there are some points that are not well distributed. So when I put this circular model and spherical model or exponential models, so they will not give a good value. But when I put it in a K-Bessel model, these are giving a good value. Though the NS ratio was high, that is, spatial dependency was less, but K-Bessel was giving a better result.
Okay.
So
you are from CSSI kernel or you are from UVKB?
No, sir. No, sir. I am from UVKB, sir. I have taken some data from there for my PhD work.
Okay.
So
okay. Which property you are working? This soil property?
Soil organic carbon and soil moisture.
Okay. So as per my suggestion, this if it is not coming good for this basic standard model, you can go always for Bessel model and this whole model or the Matter model, whatever you are talking about. You can go ahead with it, but you can always contact with me later on to further discuss on these things, because it is quite because this is the heart of the semi-Faricum model in geostatistics. If you do a good semi-Faricum model, then you can create easily the good Krieg map. Okay.
Yes, sir. And sir, in case of any kind of quantitative analysis, we generally go for the RPT study, that is 1.4 to 2, greater than 2. This is a good prediction. And also there are some about the RPQI or modeling efficiency. So, sir, is it the ultimate ones, or there are more modern approach like better than RPT or something like that?
You know this RPT thing actually came to my knowledge for the last 2 years. So before that, there are so many criteria, evaluation criteria. So it is actually evolving in nature. Earlier I used to do this G index. Later on I used MSDR. Then Lins concordant correlation analysis, LCCC. So later on I now use RPT most. So RPT now is talking about the most valuable indicator, we can say, in the recent research approach. So you can always use RPT.
Okay, sir. Sir, I have a more question for spectral preprocessing.
Subhadeep,
maybe
Subhadeep, I have a request that you will get this number from your sir, Dr. Souvik Dev, and you can then contact him. Already he has said that he is available to you, all the students, not you only. So I think you can ask him. And is there anybody else who will be asking question from students? So I think actually Dr. Chhatra, Subhadeep is doing his PhD and basically Souvik Dev is his guide, and in our university he is actually looking after all these aspects. So probably in future he will be in touch with you.
No problem.
I have only one simple question, that you said that we can calculate the field water capacity and then wilting point using that that particular app, and so I just wanted to know what is that app and where to get it. Is it available?
That Kajri soil moisture calculator is available in my institute website. You can go to kajri.res.in. In that soil moisture calculator is available there.
So based on the texture, we can calculate it, no?
Based on the texture. There are two models available in that app. One is the only based on texture. Another is the texture and organic carbon. If both are available, you can use that PSD plus organic carbon model, particle size distribution plus organic carbon model. And if you have only PSD data, means particle size distribution data, then you can choose the PSD model, particle size distribution model.
Okay, okay. Thank you very much, because this is regularly required by us, and now you know that we don't have this pressure plate apparatus. We have one, but it is not working, and so we have to go and test it in the field. It takes time. Sometimes
Yes.
some data is quickly required, and it is a very handy thing what you have suggested.
Yes, sir.
So I will now ask Dr. Shobhik Dev to summarize his lecture. And Priyabrata, you have your friend online, that is Dr. Kaushik Pradhan. After Shobhik finishes, then you can go. He left. Yes, he left. He came here to meet you, so
Okay.
I will call him.
Okay.
Very good afternoon, Dr. Chhatra. So thank you very much for this very informative lecture, which was, very required for us, for mainly the students or teachers who are working on digital soil mapping, or things related to that. So the topic was digital soil mapping and soil information status, the modern approach, by Dr. Priyabrata Chhatra. So in a very nutshell, he first said the types of soil sampling, the procedures, and very fine things that we didn't know about that. Then about the resolution, then how to do resampling to change the pixel sizes from smaller to larger and larger to smaller, and then the concept of digital soil mapping and the Scorpion approach, which was proposed by the famous McBratney in 2003. He also discussed the different approaches for soil, the modern soil mapping. For example, the state factor concept, the geostatistical approach, the petrotransfer approach. In geostatistical approach, the students always have some questions regarding the nugget, seal, and range, and what these things actually are, because they actually explains all the maps and the geostatistics. So, and the simultaneogram, and see, he in showing the diagram, he very clearly showed us the what is nugget, seal, and range. We are very thankful for that, you sir. And you also provided the information that worldclim.org is a good resource for the legacy data for bioclimate and terrain related things. So, and also we always have the NBS LUP data. And you in a very short way, you showed your some project works related to the digital soil mapping in arid western India, and how you are using the legacy data in those areas. And you also said us that already countries like US, Argentina, the total African continent, Latin America, and as well as Australia has their own soil resource map, which we still don't have for the whole India. But the NBS LUP is working on the Bhumi portal, but we need more to continue. And then you said about how we can add the proximal soil reflectance along with the lab data and satellite data in a merging way to analyze very accurate digital, or to do very accurate digital soil mapping in a larger scale also. And you then said different things in a very short span, like for example, how can we go for soil carbon mapping, soil surface water mapping for farmers in this very small farmer scale. Then the correlation of the spectral reflectance in VIS, NIR, SWIR, so that we can relate different instruments together, maybe in the Handel spectroradiometer as well as the satellite multispectral scanner. And then you said about different works you have done, tremendous work. For example, web-based soil information system you did using Google Map, and then the Android app you have developed, the digital soil map to identify different soil properties, and even you have developed a handheld device for estimation of field capacity and permanent yielding point for the farmers in which areas it is not available. So we also got the idea to about the possible app which can be developed over North Bengal. So we also would like to say, sir, that we are also working in remote sensing GIS based platforms here. We are running a soil mapping project here of the northern state of West Bengal's, which is actually funded by West Bengal's Department of Science and Technology and Biotechnology. The work is already going on in this project, so we will be very happy to collaborate with you and take your expertise with us. And I will also ask scientists who are, who want to be associate and who want to take help from you regarding the energy project. So thank you, Dr. Chhatra, for all your time, and we will continue to interact with you in future. Thank you, sir. Hand it over to
Souvik. Hello, Souvik.
Sir.
Hello.
Yes.
Dr. Chhatra, can you hear me?
Yes.
Okay, thank you very much for your very nice and elaborative presentation. We are also very much enriched the type of work you have done here and abroad, and I think we'll in future also will be in touch with you on this aspect. And Dr. Souvik is doing this kind of work with his fellows, and I also request Dr. Souvik to keep in touch with Dr. Chhatra, so that you can also develop the kind of work he has done. So I have a meeting after that, so I have to leave. So I think we will be in touch in near future also. And thank you very much for your kind consent on this platform. Thank you so much.
Thank you. I will talk with you later, sir.
Okay. Thank you.
Okay. Thank you very much. Thank you to every participant who has given time to hear this beautiful lecture. And officially we are ending this session, but I will ask Dr. Chhatra to stay because his friend has come to meet him. So all the students, if you feel, you can leave. So officially I am saying that this session is over. But Dr. Chhatra, I request you to stay, that Dr. Kaushik Pradhan has come to meet you.
আওয়াজদা কেমন আছো বলো আগে?
আরে আছি, ভালো আছি। আরে আমার খালি চুলটা কমে গেছে, আর কিছু না।
আমি তো প্রোফাইলে দেখে নিয়েছি সব।
আমি একদম ভুলে গেছি, আমি ভেরি সরি। আমার একটু প্রবলেম আছে, আমি সবকিছু মানে নাম মনে রাখতে পারি না। আমি বিপ্লবের সাথে কথা বলছিলাম, বিপ্লব বলতে বলতো আরে তুমি ভুলে গেছো আমাদের ইয়ার মেটা। আরে দিয়ে আমি বললাম যে আমি দেখ এরকম প্রিয়ব্রত একজন এসেছিল, সে কোন ইয়ার? বললো আরে আমাদের ইয়ার। তখন আমার তোর কথা মনে পড়লো, হ্যাঁ ঠিকই আছে। তো কৌশিককে বলছিলাম, তো কৌশিক বললো তুমি আমাদের তো ভালো করে দেখো নি। না আমি দেখেছি, ওকে আমার মনে আছে। অল্প সময়ের জন্য তুই এমএসসি করতে চলে গেলি।
বিপ্লব ছিল, হীরক ছিল,
হ্যাঁ
শীর্ষেন্দু ছিল।
শীর্ষেন্দু, হ্যাঁ আয় কৌশিক আয়। এই
অনেকদিন পর সামনে দেখা।
হ্যাঁ সামনাসামনি সেই দেখতে পেলাম। হ্যাঁ, দেন উই ক্যান কল ইন হোয়াটসঅ্যাপ অলসো। তো দারুণ, খুব সুন্দর টেকনিক্যাল কথাবার্তা শুনলাম, অনেকদিন পরে শোনার সৌভাগ্য হয় না। অল্প স্বল্প করে আমার কম্পিউটার থেকেও আমি জয়েন করেছিলাম, প্লাস আমি এখানে এসেছিলাম, তো তখন শুরু হয়ে গিয়েছিল।
আচ্ছা,
হ্যাঁ তোর লেকচার, সেই কারণে ডিস্টারবেন্স ক্রিয়েট করিনি। ভালো লাগছে তোকে অনেকদিন পর দেখে। হ্যাঁ ভালো থাক, দারুণ কাজ তো, দারুণ, খুব সুন্দর সুন্দর কাজ দেখলাম। ভালো লাগতো।
এই কাজগুলোর অ্যাপ্লিকেশন যদি এক্সটেনশনে কিছু করা যায় বলিস একটু সাজেশন।
আমি দেখলাম তোর সয়েল এক্সটেন্টটা দিয়ে আমার খুব বোঝার ইচ্ছে ছিল, মানে সয়েল স্যাম্পলিং এর এক্সটেন্টটা যেভাবে দেখালি, আমার কাছেও কিছুটা নতুন, জিনিসটা খুব ভালো লাগলো। হ্যাঁ, যে কোন জায়গা থেকে আমরা স্যাম্পল নিতে পারি, কোন জায়গা থেকে নিতে পারি না, সেটারও ভালো
কথা ভাব না কৌশিক। তুই আমি মাঝে মাঝে হোয়াটসঅ্যাপে ডিসকাস করলাম যে কতদিন না ওই পার্টিসিপেটরি অ্যাপ্রোচ ইন সয়েল ম্যানেজমেন্ট, এই জিনিসটা যদি একদম নতুন ডোমেন, এখন পার্টিসিপেটরি জিআইএস অনেকে শুরু করছে, আমিও মাঝে মাঝে করছি।
আচ্ছা, করছে। হ্যাঁ,
পার্টিসিপেটরি অ্যাপ্রোচ ইন সয়েল ম্যানেজমেন্ট ইউজিং অল দিস রিসেন্ট ডিভাইসেস না, মানে আইওটি।
হ্যাঁ, তুই দেখালি একটা অ্যান্ড্রয়েড অ্যাপ্লিকেশনও দেখালি, যেটা ওখান থেকে
হবে না।
হ্যাঁ, তোরা বানিয়েছিস। হ্যাঁ, যোধপুর থেকে তোরা বানিয়েছিস, ওই অ্যাপ্লিকেশনটাও দেখালি, আমি দেখলাম, ভালো জিনিস। তো তোর সঙ্গে আরো কথা আছে, এটা নিয়ে কথা বলবো, বলে তখন না হয় যদি নামা যায় একসঙ্গে কাজে, অবশ্যই। হ্যাঁ, ওকে, সো থ্যাংক ইউ ওয়ান্স अगेन। হ্যাঁ,
বিসিকেবি থেকে ওয়েট গেইন কত করলি তুই? মনে হচ্ছে তো 10 কিলো ওয়েট বাড়িয়ে রেখেছিস তো।
না কই 10 কিলো, বাজে কথা বলিস না, 10 কিলো ওয়েট বাড়িয়েছি।
কালফাল ফুরে আছে যে, মানে তো শাহরুখ খানের চেহারাটা গেল কোথায়?
না ওটা নেই, ওটা হারিয়ে গেছে, ওটা আর নেই। ওটা থাকবে কি আর এখন এই অবস্থায়? হ্যাঁ
এখন শাহরুখ দাদু হয়ে গেছে।
হ্যাঁ দাদু হয়ে গেছি। আর হচ্ছে যে হ্যাঁ এসেছিস, ভালোই হলো। হ্যাঁ অনেকদিন পর। হ্যাঁ
এ হচ্ছে কৌশিক হচ্ছে আমার পাশের রুমে থাকতো, আর এর হচ্ছে শাহরুখ খানের যে চুল ছিল না, ওই তখন 2-3টে ফিল্ম রিলিজ হয়েছিল, পুরো সেই প্যাটার্নেই থাকতো হোস্টেলে সবসময়।
হ্যাঁ
ঠিকই আছে, কৌশিক আসলে এক্সটেনশনের লোক না, সবসময় একবারে এক্সটার্নাল ফিচার নিয়ে তারা সবসময় ইয়ে থাকে।
ঠিক আছে, ওটা নিয়ে কথা হবে। হ্যাঁ অ্যান্ড্রয়েড অ্যাপ্লিকেশন নিয়ে। হ্যাঁ ঠিক আছে, ওকে, থ্যাংক ইউ।
আরেকটা তোকে রিকোয়েস্ট, সেটা হচ্ছে যে ওই আমাদের এখানে কি বলতো, এই যে ধর সফটওয়্যার বেসড ইরিগেশন যে ওয়াটার গুলোকে মানে দরকার, আমার মানে দরকার মানে আমরা ওই যে এফডিআর বা এগুলো জোগাড় করি না, ইন্ডিয়াতে ওরকম পাওয়া যায় না, বিদেশ থেকে এরকম যদি ছোট ছোট আমরা ফার্মার্স ফিল্ডের যদি এরকম ময়েশ্চার স্ট্যাটাসটা দেখতে পারি এবং তাদের ইরিগেশন করতে পারি। আমাদের এখানে একজন ওই বিদেশি এসেছিলেন, ওই বিপ্লবের সাথে কাজ করেছিল, জি ডট বলে একটা হ্যান্ড হেল্ড ওই তোর ওই জিপসাম ব্লকের মতন ঢোকানো ছিল। ওরকম যদি এটা ডেভেলপ করতে পারিস না প্রিয়ব্রত, তাহলে আমাদের এখানে ফার্মারদের খুব সুবিধা। আমরা তো ফান্ড ক্রাঞ্চে থাকি না।
আমরা যে অবস্থা, আমি না একজন ইন্ডাস্ট্রির সাথে কোলাবোরেট করেছি, ওই তুমি যেটা বলছো ওইটা আমিও তৈরি করার চেষ্টা করছি, অলমোস্ট করেছি অনেকটা, তো মোস্ট প্রবাবলি ওটা করে ফেলতে পারবো। ওইটা হলে খুব হেল্পফুল হয় অ্যাকচুয়ালি, তুমি যেটা বললে।
হ্যাঁ মানে এখন কি বলতো, ফার্মাররা যথেষ্ট মানে কি বলবো ওয়াকিবল হয়ে গেছে তো ব্যাপারগুলো নিয়ে, ওরা ফার্টিলাইজার নিয়েও নিজেরা করতে পারে। জলটা যদি ওদেরকে ভালো করে বুঝিয়ে দেওয়া যায় না, যথেষ্ট পেট্রোল ডিজেলের তো দাম হয়ে গেছে, ইলেকট্রিকটা ফ্রি দিচ্ছে ঠিক আছে, কিন্তু অনেক সময় পেট্রোল ডিজেলে দিতে হয় ওদের, ওরা খুব কনসার্ন হয় ব্যাপারটা। এটা করলে আমি ওই সোম শুভ্রকেও বলেছিলাম।
আচ্ছা
যাই হোক, সোম শুভ্র তো ও যে ওই ইনস্ট্রুমেন্টটা ডেভেলপ করেছিল, আমি বললাম একটা কম দামের একটা ইনস্ট্রুমেন্ট ডেভেলপ করো, যাতে আমরা হচ্ছে ময়েশ্চার স্ট্যাটাসটাকে কুইকলি দেখতে পারি, খুব ভালো হয়। তো যাই হোক, তোকেও বলছি, হ্যাঁ যেহেতু তুই ডাইরেক্টলি এরকম একটা ফার্মার্স ফিল্ডের কাজ করছিস, তাহলে আমাদের খুব ভালো হয়।
ঠিক আছে ঠিক আছে, অবভিয়াসলি মাথায় থাকবে।
ঠিক আছে, থ্যাংক ইউ ভেরি মাচ, উইল কিপ ইন কন্টাক্ট ডেফিনেটলি। আমার জানা রইলো, আমিও থাকবো, হ্যাঁ একসাথে কাজ করবো সবাই মিলে।
কন্টাক্ট অ্যাড্রেস তো আমার ইমেলে ঢুকে গেছে, তাছাড়া প্রোফাইল সব দেখে একদিন দেখছি।
হ্যাঁ ফোন নিয়ে নেবো, কোনো অসুবিধা নেই, কোনো অসুবিধা নেই।
সবিকের কাছে সমস্ত কন্টাক্ট আছে আমার।
হ্যাঁ হ্যাঁ ঠিক 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 আছে, ওকে হ্যাঁ এন্ড করলাম।
খুব ভালো লাগলো সবার সঙ্গে দেখা হয়ে, খুব ভালো লাগলো। হ্যাঁ স্পেসিফিক্যালি করোনা কালে কারোর সাথে দেখা হয় মুশকিল।
আর তুই থাকিস তো অনেক দূরে না, জোরপুর, বাপ অনেক দূরে।
আরে 1 বছর হয়ে গেছে, যেতে পারিনি করোনার জন্য। গত নভেম্বরে কালী পুজোয় বাড়ি গিয়েছিলাম লাস্ট।
আচ্ছা আচ্ছা,
তারপর আমি ক্যাম্পাস থেকে বের হইনি, 1 বছর হয়ে গেল।
ঠিক আছে, ওকে
ঠিক আছে, ওকে।